Alright, so we're on number 37. So the coordinates of the endpoints of segment AB are 0, 0, and 0, 6. The equation of the perpendicular bisector of AB is, alright, so we're given two coordinates and we want to know the perpendicular bisector. So let's just draw a picture. We have a segment, right, AB, and A is at 0, 0, and B is at 0, 6. Alright. Now, if we were going to draw that, let's fix something. Sorry. Let's draw a really quick coordinate axes here, right? 1, 2, 3, 4, 5, 6, 7. Let's go to 7. So A is at 0, 0. B is at 0, 6. So let me just get my ruler out. Okay. So here's my segment, right? The perpendicular bisector, obviously, first of all, it bisects this segment. The segment is 1, 2, 3, 4, 5, 6 units long. So the line has to go through the midpoint, okay, which is right there. Now, if it's got to be perpendicular, it's got to be exactly left to right. Right? Because this has to be perpendicular. This line is the equation of the line y equals 1, 2, 3. Okay? It's a horizontal line that goes through 3 on the y-axis. That's the perpendicular bisector of that segment. So that was choice 4. Okay? 38. Which equation represents the perpendicular bisector of AB, whose endpoints are 8, 2, and 0, 6? So let's draw a quick graph. And let me see. I'll make every quarter inch be, so this is going to make it so it goes in 8 in each direction, and that's all I need. Okay, I have 8, 2, 8, there's 8, 2, and I have 0, 6. So here's my segment, right? Now, I want to know where the middle of this line is. So in this problem, it was easy, right? Because I could just count, because this line is exactly vertical. So when the line is vertical or horizontal, it's easy because you can count. But this time, it's not as easy, all right, because it's diagonal. So A is 8, 2, B is 0, 6. We can use the midpoint formula. Which is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So this would be x1, y1, x2, y2. So we have 8 plus 0 divided by 2, comma, 2 plus 6 divided by 2. That's 8 over 2, comma, 8 over 2. 4, comma, 4 is the midpoint. 1, 2, 3, 4. 1, 2, 3, 4. Okay? The other way I could have done this is going from B to A, I go over 8 and down 4. So instead I could just go over 4 and down 2, which is half as much, right? So that's another way you could do it, but either way, this is the midpoint, and this is at 4, comma 4. Now, I need the slope of this line. So the slope of AB, now I can use y2 minus y1 over x2 minus x1, or just look at graph. I'm just going to look at the graph. To go from B to A, I got to go to the right 8 and down 4. So, or in other words, I go down 4 and to the right 8. So down 4 and to the right 8, which is negative 1/2. Now for perpendicular bisector, right, I have to do the negative reciprocal of the slope. So the negative reciprocal of slope, negative 1/2, is 2, which is 2 over 1. So I'm going to go up 2 and to the right 1. And then it's going to go down 2 and over 1, down 2 and over 1, so I'm going to cross right there. Down 2 over 1, down 2 over... Actually, it's supposed to cross, let me see. It's really supposed to cross right here, I believe. So let's just fix this thing up a little bit. Alright. If I go down 2 and over 1, that would be 3, 2. Down 2 over 1, so it crosses here. Down 2 over 1. Down 2, yep, it crosses right here. So here's my y-intercept, right? Y equals mx plus b. Y equals, my slope is 2x, and my y-intercept is minus 4. Choice 1. Okay? There you go. Write an equation of the perpendicular bisector. Okay, I'm going to draw a graph because they've given me a graph, so I'm going to use it. Whether I need it or not doesn't really matter because I'm going to use it anyway just to double check my work. So if you're ever given a graph, you always use it to double check. So negative 1, 1. And let me try to make this a little darker. Okay. And and 7, negative 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Here's my segment. Alright, just give me a second. Let me get out my other ruler. It's much better. So, this time I'm just going to count, okay? I got to go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So, instead of going 8 right and 6 down, I'll go half of that to find the midpoint. So 4 to the right and 3 down. 1, 2, 3, 4, 1, 2, 3. There's your midpoint. Okay? Now, the slope is, we went down 6 and to the right 8. So the negative reciprocal is positive 8 over 6, okay, which is 4 over 3. So from this point, I'll go 1, 2, 3, 4, 1, 2, 3. I'll also go down 4 and to the left 3. 1, 2, 3, 4, 1, 2, 3. This is perpendicular because the slopes are negative reciprocals, and my y-intercept is 1, 2, 3, 4, 5, negative 6. So y equals mx plus b. Y equals m is 4/3 x, 4/3. B is negative 6, so minus 6. Okay? Now we're going to start talking about systems of equations, linear quadratic systems, right? These are those long problems. But some of these are shorter multiple choice problems. Which graph could be used to find the solution to the following system of equations? For this one, you just pull out your calculator. Y equals negative x plus 2 and x squared. I'm going to graph them. Okay? Now I look for which one is that graph. It's not the first one, it's not the second one, it's the third one. You see? They're the same. Choice 3. By the way, if you wanted to know what the solution was, you just want to find the intersection of those 2 points. So second, calculate, intersect. We want to know where the graphs cross. So I put the blinking cursor near the left point of intersection. Enter, enter, enter. Negative 2 comma 4. And if I wanted to know the other point, which is an answer, which is a solution to the equation, second, calculate, intersect, enter, enter, enter. 1, 1. Okay? So that's just a review on how to do that. But we didn't need to do that for that problem. We just needed to look at which graph is the same. Choice 3. So let's put up here, use calc. Given the system of equations y equals x squared minus 4x and x equals 4, the number of points of intersection is, okay, well, here's what you do. You use the calculator. Y equals x squared minus 4x. Now we can't put x equals 4 into the calculator. It only does y equals. So let's just plot x squared minus 4x. There you go. Okay? Now, x equals 4, remember, is a vertical line through 4 on x axis. So if you have a vertical line going through 4, right, it's going to be going right through the graph at one point. Okay? And that point, all it wants to know is a number of points of intersection. So it's only going to cross that parabola at one point. So the answer is 1. So use calc. What is the solution to the given system of equations? Ready? We're going to use the calculator. We're going to plug in x squared minus 6x plus 10. Now this one we can plug in, we just have to rearrange it, right? Y plus x equals 4, subtract x. Y equals negative x plus 4. Negative. Y equals negative x plus 4. Graph. Alright, it looks like there's only one solution. Where is that point? Second, calculate, intersect, put the blinking cursor near that point, enter, enter, enter. 2, 2. So, it looks like there's two places that it crosses, really. Right? So 2, 2, you know what we can do? Zoom, and let's do zoom in. And let's zoom in at the origin. So I'm moving the little blinking thing to the origin. And look, there is 2 points where it crosses. So second, calculate, intersect, okay, here it comes. Here's my cursor. Bringing it over near the second point. Enter, enter, enter. 3, 1. Use calc. See how useful the calculator is for these problems? Here's another one. In which quadrant will they intersect? All right, well, let's look at the graph. Clear, clear. 1/4 x, you got to put it in parentheses, or you have to make that 1/4 0.25. So let's circle 1/4 and put or 0.25. I'm just going to leave it as 1/4. Minus 3. And then we have x squared plus 8x plus 12. We want to zoom back out, or we can just hit zoom and then go to z square, or z, let's do z square and see what happens. Yeah, it didn't zoom out enough. So zoom, z standard. All right. In what quadrant do they intersect? Well, this is the first quadrant, second quadrant, third quadrant, fourth quadrant in the third quadrant. That's it. How easy is that? Use calc. What is the solution to the following system of equations? Watch this. We got x plus 3 squared minus 4, and we got 2x plus 5. So we have two solutions, right? Second, calculate the intersect. Let's start with the one on the right since it's already there. Enter, enter, enter. 0, 5. So the only choice is choice 3. But let's just double check. Second, calculate, intersect. Let's go over to the left point. Enter, enter, enter. -4, -3. There it is. Okay? So, use calc. 45. When solved graphically, what is the solution to the following system of equations? Okay, let's do the same thing. X squared minus 4x plus 6 and x plus 2. Graph. There's two answers. Alright, so we know it's not 1 or 2, it's either 3 or 4. So second, calculate, intersect, bring it over near this first point, enter, enter, enter. 1, 3. There it is, choice 3. Let's just double check. Second, calculate, intersect, bring it over near the second point, enter, enter, enter. 4, 6. So there it is. Use calc. Alright, this one we actually have to solve, right? On the set of axes below, solve the following system of equations graphically for all values of x and y. Okay? So, first let's work with this quadratic equation. We have to get into y equals ax squared plus bx plus c. So let's start doing that. So I hope you guys know FOIL. X minus 2 squared is the same thing as x minus 2 times x minus 2. Then if I do FOIL, I'm doing x times x, which is x squared, x times -2, which is -2x, -2 times x, which is -2x, and -2 times -2, which is positive 4. Then I still have my plus 4 at the end. Keep going. X squared minus 4x plus 8. Okay? Now, I'm in y equals ax plus b form. That's what we want, right? So here's my a, which is 1. Here's my b, which is -4. And here's my c, which is 8. And the reason why I want that is because x equals -b over 2a is my axis of symmetry. So that's going to be -4 over 2 times 1, 4 over 2, which is 2. So, x equals 2 is my axis of symmetry. It's right here. Now, that's also my middle value in my data table, right? And I go let's plug in our equation. I had x squared minus 4x plus 8. Now let's do second graph to go to table. So there. -1, 0, 1, 2, 3, 4, 5. we always pick 3 below and 3 above. And look, I can pick my y values right off the thing here. It's 13, 8, 5, 4, 5, 8, 13. Okay? Whoop. There you go. So I'm just going to plot that. Negative 113. I don't know if that's going to fit, but it might. Negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 5. 1, 2, 3, 4, 5. 2, 4. And then I know it's going to be 3, 5, 4, 8, and 5, 13. There's my parabola, right? No problem. Now let me work with my line. 4x plus 2y equals 14. You know that you gotta fix this thing up. 2y equals negative 4x plus 14. Divide everything by 2. Y equals negative 2x plus 7. So I go through 7. 1, 2, 3, 4, 5, 6, 7. And I'm going down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1, down 2 to the right 1, down 2 to the right 1. Okay, so it looks like I'm only touching this graph in one place. Right here. So the solution is 1, 1, 2, 3, 4, 5. Okay, let's just double check with our calculator. I had negative 2x plus 7 was my linear equation. So now when I graph that, it should look like what I have. And it does. Okay, see, it just touches it there. Let's check. Second calculate, intersect, enter, enter, enter. .9999999, which is 1, and 5.000014, which is 5. Sometimes the calculator does this, but you can see that's 1 and that's 5. 1, 5. So it checks. Okay? That's all you have to do. Okay? You don't have to label anything else. I mean, you can if you want, but you don't have to. That's it. Okay, let's look at this one. 2x squared minus 4x equals y plus 1. Subtract 1. I have y equals 2x squared minus 4x minus 1. A is 2. B is negative 4. C is negative 1. Remember, y equals ax squared plus bx plus c. So now x equals negative b over 2a equals negative 4 over 2 times 2. That's 4 over 4. That's 1. So x equals 1 is the line of symmetry. Okay, it's hard to see that, but that's the line x equals 1. Now let's use our table. And 1 we know is going to be the middle value. And we're going to want to do 0, negative 1, negative 2, and 2, 3, 4. And we just use the calculator to make it easy. Uh, 2x squared minus 4x minus 1. So we want to see the table. Negative 2, 15. Negative 1, 5. 0, negative 1. 1, negative 3. 2, negative 1. 3, 5, 4, 15. Let's plot those points. We don't have to do the 15 because it's going to be off the graph. Let's do the others. Negative 1, 5. 0, negative 1. 1, negative 3. And then we're going to go 2, negative 1, 3, 5. And that's all we need, okay? Because it's going to go off the graph otherwise. Okay, there's our parabola. Now let's look at our line. X plus y equals 1. Subtract x. Y equals negative x plus 1. So there's my slope, which is negative 1 over 1. My y-intercept is 1. And my slope is down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. Yeah, that's all I really need. I just need 2 points to draw a line. I already have 3. So I'm just going to draw my line. So it crosses at 2 points. Right, it crosses here and it crosses here. Let's see what those points are. We had negative, our linear equation was negative x plus 1. Alright, second calculate, intersect, enter, enter, enter. Negative a half and 1 1/2. So at negative a half, 1 1/2, like right here, well right here-ish, right in the middle of that box, negative 1/2, negative. Alright, they have it as negative 0.5, which is the same thing, but I'll just, so I don't want to confuse anyone. Negative 1.5. You can write it as a fraction if you want, though. That's one solution. And the other one, second calculate, intersect, enter, 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 2, negative 1. And that one's already right on. So I just kind of fudged this one to make sure it looked like it was crossing that point. Okay? So that's that problem. Now we have this other problem. Let's see. First I'll work with the quadratic. Okay, so here's my A, it's 1. Here's my B, it's negative 4. Here's my C, it's 1, because we're looking at ax squared plus bx plus c. X equals negative b over 2a. That's going to equal negative negative 4 over 2 times 1, which is 4 over 2, which is 2. So x equals 2. Is my line of symmetry. It's also the middle value in my table. And then I go 3 below, and 3 above. And then I look at my graph, my table, I mean. So x squared minus 4x plus 1. X squared minus 4x plus 1. Second table. Negative 1, 6, 0, 1, 1, negative 2, 2, negative 3, 3, negative 2, 4, 1, 5, 6. Okay, so let's plot it. Negative 1, 6. Zero, 1. 1, negative 2. 2, negative 3. 3, negative 2. 4, 1. 5, 6. So, there's my parabola. Okay. And now I'm going to do the linear equation. 2y plus 16 equals 4x. This is my line. Subtract 16. I got to get it in y equals mx plus b form, right? Here's my m is 2 over 1. And I start at negative 8. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So you can see what happens, right? It just crosses, well, it doesn't even cross, it just skims right by that one point. It touches it at one place, right there, which is 1, 2, 3, negative 2. Let's check though. I had 2x minus 8. That looks like what I have here, right? Let's double check the point. .99999, that's 3, and negative 2.0002, that's negative 2. 3, negative 2, that's what I got. I'm just going to zoom in to make sure there's no, it only touches once, because sometimes it may touch twice, and the calculator you really can't tell. So zoom in. I'll zoom in right where the blinking cursor is, which is right near that point. And now I'll get a much clearer view of what's happening. See? It's just touching it at one point. Okay? Now I'll go back to zoom, standard. Okay, that's 48. Last one of these, 49. This one's a circle, and I know that because I have two variables squared. I have a y squared and an x squared. Okay, so this is a circle, and the center is negative 3. All right, let me help you out here. X minus h squared plus y minus k squared equals r squared. That's the equation of a circle. What I have is x plus 3 squared plus y minus 2 squared equals 25. So my center, which is h comma k, is, it's always the opposite sign. So if this is positive, h is negative 3. And if this is negative, then k is positive 2. It's always the opposite sign. Now my radius is r. but I know r squared is 25. So the square root of r squared equals the square root of 25. R equals, you see how I crossed out the squared and the square root? Because they cancel. I'm left with r equals the square root of 25, which is 5. So what I have here is, let me just get out my compass. Okay. I have a circle with the center is -3, 2. Right here, and the radius is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going to use this compass to help me draw the circle. Okay. Now, the other thing I have is my linear equation. 2y plus 4 equals -x. Of course I have to put that in y equals mx plus b form. Y equals -1/2 x minus 2. Okay? So my slope is -1/2, and my y-intercept is -2. So -2 is right here. Then I got to go down 1 and to the right 2. Down 1 and to the right 2. And also up 1 and to the left 2. Up 1 to the left 2. Up 1 to the left 2. Up 1 and to the left 2. So we're going to have 2 points of intersection. Right? Two points. Now you can't use the calculator for this, so we'll just count. 0, -1, -2, -0, -2, and -8, 2. Okay, that's it. You can't use a calculator for this. So let's just do one quick thing. For number 46, put use calc at the top. 47, use calc. 48, use calc. 49, you can't use the calc. All right. Let's see. 50. Problems are a little different. Line segment AB has endpoints A 2, -3 and B -4, 6. What are the coordinates of the midpoint? So x1 plus x2 over 2, y1 plus y2 over 2. We have 2 plus -4 over 2, comma, -3 plus 6 over 2. That's -2 over 2, comma, 3 over 2. That's -1, comma, 3 over 2. Three over 2 is 1 and 1/2. It's choice 2. Okay? Got to know how to go from mixed number to improper fraction. Hope you didn't forget. We have a square. What are the coordinates of the midpoint of LN? Diagonal LN. Well, I mean, it's a square, so look, I got to go up 1, 2, 3, 4, 5, 6, 7, and to the right 1, 2, 3, 4, 5, 6, 7. But instead of going up 7 and to the right 7, I can just go up half of 7, which is 3.5. 1, 2, 3.5. And to the right, 1, 2, 3.5. So the midpoint is -1, -2.5, comma, 1, 2, 3, 4.5. Or you could use the midpoint formula. L is 1, 2, 3, 4, 5, 6, -6, 1. And N is 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay? Whatever you want to do. I think it's easy just to look at it and count, but if you want to use the midpoint formula, you go ahead. I would do the midpoint formula anyway just to check. Midpoint. 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 -2 plus 6 over 2, -4 plus 2 over 2, 4 over 2, -2 over 2, 2 comma -1. Straightforward. In the diagram below of circle C, QR is a diameter, Q is 1/8, and C is 3.5, comma 2. What are the coordinates of R? Well, look, to get from 1, comma 8 to 3.5, comma 2, I go to the right a certain amount and down a certain amount. I go to the right from 1 to 3.5, so that's 2.5, and I go down from 8 to 2, so that's 6. So do the same thing. 2.5 and 6. So I do 3.5 plus 2.5 is 6, and I do 2. Now since I added 2.5 to 3.5 because I went to the right. Now since I'm going down, I'm subtracting 2 minus 6. Okay? Can't get any easier than that. Don't make the problems any harder than they are. A line, oh, let me just see something. Okay. A line segment has endpoints of this and this. What are the coordinates of the midpoint? So, x1 plus x2 over 2, y1 plus y2 over 2, 3x plus 5 plus x minus 1 over 2, 3y plus negative y over 2. 4x plus 4 over 2, 2y over 2. 2x plus 2, comma, y. That 2 divides into both, okay? 2x plus 2. That's where everyone's going to make a mistake. So 2x plus 2, comma, y. Midpoint, x1 plus x2 over 2, comma, y1 plus y2 over 2. 7 plus negative 3 over 2, negative 1 plus 3 over 2, 4 over 2, 2 over 2, 2 comma 1. Okay, so I have circle M. I'm just going to draw a circle. Whoops. Okay. Segment AB is the diameter of circle M. The coordinates are negative 4, 3 of A are negative 4 comma 3, and M is 1 comma 5. So this is 1 comma 5. And negative 4 comma 3 is somewhere over there, right? Now I'm going to go up a certain amount. This is the same type of problem as before. From negative, I'm sorry, if I'm going up first, from 3 to 5 is 2, and then from negative 4 to 1 is a total distance of 5. So I do the same thing. I go 2, 5. So I'm at 1 comma 5. So I go, I'm at 1 comma 5. So from 1, I mean from my 5 I go up 2, so plus 2. And I go from 1 to the right 5, so plus 5. So my point is going to be 6 comma 7. Okay? Choice 1. Same deal. Let's see. Maybe I should draw a quick set of axes here somewhere. Should I? No, that's fine. A is negative 3, 6. And M is negative 5, 2. So, what's the coordinate of that point? Well, to go from 6 to 2, I go minus 4. And to go from negative 3, I'm just going to say 4, right? I go 4 down. And to go from negative 3 in the x to a negative 5 in the x, I go 2 to the left, right? So 4 down, 2 to the left. So from negative 5 comma 2, I go 4 down, so minus 4, and 2 to the left, so minus 2. So I end up at negative 7, negative 2. Choice 4. So if we want to go back here and say 5 to the right, 2 up, 5 to the right, 2 up, we can do that, right? And if we want to go back to this one, 2.5 to the right, 6 down, 2.5 to the right, 6 down. Okay? So, we have circle O. We have R and S. So, x1 plus x2 over 2, comma y1 plus y2 over 2. 3a plus a minus 6 over 2, comma 2b minus 1 plus 4b plus 5 over 2. 4a minus 6 over 2, comma 6b plus 4 over 2, right? Divided into both, you get 2a minus 3, comma, divided into both, 3b plus 2. That's as far as you can go, okay? And that's it for now.